All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll show you the correct answers. So for this factoring, you're going to factor out a 5x, and you're going to be left with x squared minus 4, and then that'll factor as x minus 2, and then x plus 2. And so that would be the answer there. For the math knowledge question, it tells us 20% wanted cranberry, 40% orange juice, 20% grapefruit, and then the remaining wanted tomato juice. So 20, 40, 20 is 80. So that means that the remaining that wanted tomato juice was 20%. And it says each student only wanted one juice and 250 preferred tomato juice. Well, 20% of the total is 250. So that means that the total would have to be 1,250. Because you basically would just take 250 and multiply it by 5. Okay, so we are looking at lesson 83. We're looking at simple probability, and then we're going to look at independent events and replacement. So hopefully you'll understand these simple probability questions, independent events, and replacement after this lesson. The study of probability is based on the study of outcomes that have an equal chance of occurring. So your outcomes have to have an equal chance of occurring. We call activities such as flipping coins, rolling dice, blindly selecting cards from a deck, or drawing marbles from an urn experiments. And the individual results are outcomes. And all of the outcomes from flipping coins, rolling dice, selecting cards from a deck, or drawing marbles from an urn, those are all outcomes that have an equal chance of occurring because it's all based on chance. You have a 1 out of 2 chance of flipping a heads when you're flipping a coin. You have a 1 out of 2 chance of flipping a tails. You have a 1 out of 6 chance when you're rolling a dice of getting any of the 6. You have a 1 out of 52 chance of selecting any card from a deck of cards. And then for a marble, you're going to pick 1 out of however many you have. That's the probability of getting a specific marble. The probability of a particular event is the number of outcomes that satisfy the requirement divided by the total number of outcomes in the sample space. Okay, so when you're looking at probability of a particular event, you're going to take the ones that satisfy the requirement they give you and divide it by the total outcomes that you have. So let's look here. We have 2 fair dice are rolled. What is the probability of getting a 7 and then a number greater than 8? When you're dealing with 2 fair dice, you are going to have to make a chart. And so you're going to set up your chart like this. You can roll a 1, 2, 3, 4, 5, or 6 for the first die. And you can roll a 1, 2, 3, 4, 5, or 6 for the second die. And you're going to make a chart like this. And the way that you figure out the number that you rolled is to add up the sum of the 2 die. Well, if you roll a 1 and a 1, that sum is 2. 3, 4, 5, 6, and 7 is going to finish out that column. And then we would have 3, 4, 5, 6, 7, and 8. And then 4, 5, 6, 7, 8, 9. 5, 6, 7, 8, 9, 10. 6, 7, 8, 9, 10, 11. 7, 8, 9, 10, 11, and 12. Those are the outcomes that you can have. And it says, what is the probability of getting a 7? Well, if you look at your chart, you can get a 7 any of these ways. So that's 1, 2, 3, 4, 5, 6. So for part A, we have 6 out of, well, we can roll a total of 36 different things. And so we have a 1 out of 6 chance of getting a 7. Okay, for part B, this has a number greater than 8. Well, the numbers that are greater than 8 would be 9, which is here, 10, 11, and 12. So we have 10, numbers that are greater than 8 out of 36. And so we have a 5 out of 18 chance of getting a number greater than 8. So that's how you do those. Once you get proficient with rolling 2 dice, you may not need to draw this chart, but for a little bit, I would assume that you would want to draw that chart or look back at it in your notes every time. You would have to draw it on your test. You won't be able to go back and look in your notes. So you do want to make sure you understand how you get that chart. Now look at independent events. Events that do not affect one another are independent events. The probability of independent events occurring in a specific order is the product of the probabilities of the individual events. If I toss a coin and I roll a dice, those don't affect each other. I mean, if they hit each other, I guess they technically would. But if I toss it, the coin, and then I roll the die separately, those are independent events, because if the dice lands on a even number, that's not going to affect what the coin is going to do. So those are examples of independent events. So we have a fair coin toss 3 times. What is the probability that it comes up heads every time? Well, each flip is independent of the previous flip. It doesn't matter what it landed on the last time as to what it's going to land on this next time. So the first time, it is a 1/2 chance of landing on a head. The next time, it is also a 1/2 chance. And the third time, it's a 1/2 chance. And you multiply those together to get 1/8. And so the probability that it came up heads on all 3 of those flips is a 1 in 8 probability. And I'll show you what the 8 outcomes could have been. We could have had heads, heads, heads. We could have had heads, heads, tails. Heads, tails, heads. Or we could have had heads, tails, tails. We could have had tails, heads, heads. Or tails, heads, tails. We could have had tails, tails, tails. Or tails, tails, head. And those are the only combinations you could have. And those are 8. And the only one that is head, head, head is that first one. So 1 out of 8. Okay? Looking at this one. A fair coin is tossed 4 times and it comes up heads every time. What's the probability it'll come up heads on the next toss? Well, this is just a 1/2. Probability it'll come up heads on the next toss is a 1/2. It didn't say what is the probability that it'll come up heads on all of the tosses. It just says on the next toss. Well, the next toss is still a 50% chance of hitting heads. So that's why you just have a 1/2. Okay? So you got to be careful with the wording there. Now looking at replacement. The probability of a certain outcome on the second draw is affected by whether or not the first item is returned before the second is made. So if I am doing some drawing, they're going to have to tell you whether the first draw is replaced or not, okay? Because that's going to change the outcome for the second draw. So we have an urn. It contains 2 black marbles and 2 white marbles. A marble is drawn randomly and replaced. Then a second marble is randomly drawn. What is the probability that both marbles are black? And then if the marble is not replaced, what is the probability that they are both black? So we'll start with A. We have 2 white marbles and 2 black marbles. So we have 4 marbles total. The first time we wanted a black marble. Well, we have a 1 out of 4 chance of drawing a black marble. No, I'm sorry, we have a 2 out of 4 because we've got 2 black marbles. And then we replace that marble and we draw again. And we want a black again. Well, again, we have 2 out of 4. And so basically 1/2 times 1/2 is just 1/4. We've got a 1 in 4 chance of drawing 2 black marbles on those 2 draws. Now for the second one. The first draw is still 2/4 because we had 2 black marbles and we had 4 marbles total. But we drew a black marble the first time and then it is not replaced. So now we only have 3 marbles and it wants it to be black. Well, we already took one of the black marbles, so we only have one left. So 1/2 times 1/3 is 1/6. Now we only have a 1 in 6 chance of getting 2 black marbles. Okay, so that's how replacement would affect your answer. Looking at another one. 2 cards are drawn from a 52 card deck without replacement. What is the probability that the first one is red and the second one is black? When we draw the first time, we've got 52 cards and we have a red. Well, there are 26 red cards. And it says without replacement. So after we draw that card, we now have only 51 cards. And we want it to be black. Well, we drew a red card before, so we still have 26 black cards. And so if you multiply and reduce, you're going to end up with 13 over 51. That is your probability of drawing a red card and then a black card without replacing the first red card. So hopefully that helps you a little bit with probability, independent events, and replacement. Your homework is 1 through 30. You need to make sure to do that tonight so that you'll go over any questions you have tomorrow.